Hi everyone, I am Dr. Subbarao from RVIT Institute of Technology. In this video, I am going to explain why do metals conduct electricity. The free electron theory of metals explain why metals conduct electricity. In general, it was accepted that the electrons, the valency electrons, are involved in electrical conductance in metals and alloys. So the valency electrons, that means the outermost electrons present in an atom, are the responsible for the conductance of the material. Here, there are three theories describing the conduction of electricity of materials. The first theory was classical free electron theory. This classical free electron theory was proposed by Paul Drude in 1900. After that, this was extended by Lorentz in 1909. Hence, this theory is also known as Drude and Lorentz free electron theory. According to this theory, the valency electrons becomes free in metals and moves randomly within the metal. These free electrons are responsible for the electrical conductivity in metals. So according to the classical free electron theory, the free electrons present in the outermost orbits of an atom are responsible for the conduction of the electricity. And the next one is the quantum free electron theory. This quantum free electron theory was proposed by Sommerfeld in 1928. He modified some of the key points in the classical free electron theory and proposes this quantum free electron theory. According to this theory, the free electrons move in a region of constant potential and obey the quantum laws. That means the atoms present in a molecules and all the molecules have the atoms. These atoms have the valency electrons and each electron is specifically rotated in a particular region. That means they have the boundaries. Simply we call it bands. So each bands they are having the bands and the electrons will randomly rotate in this bands only, and these electrons will obey the quantum laws. So those electrons which obey the quantum laws, then only the materials conduct the electricity. But these two theories, this classical free electron theory and the quantum free electron theory, these two theories fail to explain the categorization of the electrical material. That means the formation of the conductors, semiconductors, and the insulators, how they are formed and how the conductance of these materials. These are not explained by the free electron theory in classical and quantum free electron theory. For this another theory, band theory. Here the name itself indicates the band. That means here they proposes the formation of bands within the atoms. Here this band theory was proposed by Felix Bloch in 1928. According to this theory, the free electrons exhibit wave character as they move between the atoms in a solid. That means in the previous, they considered as the electrons moving in a particle nature. But according to the band theory, Felix proposed that the free electrons exhibit the wave character. That means he considered the movement of the electrons as a wave as well as in particle nature. So we know that the solid atoms have the various energy bands filled with the electrons. That means in an atom, there are several shells. That means K shell, L shell, M shell, so and so on. So each shell having the discrete amount of energy. That means each orbital is associated with a particular amount of energy. Here there are the different energy levels forms the different bands. That means each energy level having the same energy comes under the same band. And if there is a difference in their energies, they forms different bands. So each band associated with the same energy. Two different bands have the different energies. That means the formation of bands within the atoms. And all these energy bands, the electrons remains bound to the nucleus and have the discrete energy levels. That means all are bounded with the nucleus. And the electrons present in the outermost orbit, that means outermost energy level, they are called the valency electrons. And the outermost band itself called as a valency band. So here the valency electrons and valency band. That means the outermost orbit, that means valency, the last orbit having the electrons. Those are the valency electrons. And the band is called the valency band. Here, this valency band have the electrons. This is the valency electrons. If you see in diagrammatic representation, I am showing here for easy understanding. Here, the valency band, this is the outermost orbit having the electrons. This valency band have the electrons, free electrons. So these electrons, the valency band, above the valency band, there is another band, that is the conduction band. Here, this conduction band also having the electrons. These valency band having the electrons moves to the conduction band. And the electrons coming back to the valency band. This is the way the conduction of electricity. That means that material conduct electricity by the transfer of electrons from valency band to conduction band. Here, there is a huge gap in between the valency band and conduction band. This gap is called the Farabian energy gap. And this is the Farabian energy gap in between the valency band and conduction band. And this is the conduction band. Conduction band is the which is above the valency band. And here the conduction band also having the electrons, but these electrons are not bound to the nucleus. And these are electrons present in conduction band are called the conduction electrons. Here the electrons present in valency band are called valency electrons, and the electrons present in conduction band are called conduction band. Due to the presence of these conduction band, the materials conduct the electricity. Here the electricity passes through the solids because of these free electrons present in the conduction band. And there is a gap. This is the free energy, forbidden energy gap. This is also known as the Fermi energy gap. So the gap is in between the valency band and the conduction band. So based on this band theory, the materials are categorized as conductors, semiconductors, and insulators as per the bands. So here this is the energy. All the materials having the valency band, whether it is a conductor, semiconductor, or insulator, these must have the valency band. And all the valency band have the valency electrons. And these valency electrons above, there is another one, conduction band. This conduction band is separated by a distance, Farabian energy gap. So all the conduction bands are separated by some distance, so that is the Farabian energy gap. Here, this Farabian energy gap will place a key role for the conduction of the electricity. If you see in this conductors, the distance between the valency band and the conduction band is very low. Sometimes this valency band and conduction band may overlap with each other. That means there is a very less Farabian gap. Such kind of materials are having the high conductivity. And here the distance between the valency band and conduction band is quite more when compared to the conductors. This one is the acting as a semiconductors. And the next third one is the insulator. This insulator having the higher forbidden energy gap in between the when compared to the conduction band when compared to the conductor and the semiconductor. If you see from conductors, the valency electrons present in valency band, they absorb some amount of energy and goes through the conduction band. This is the activated electrons. These electrons enter into the conduction band. This is the way of conducting the electricity in conductors. Coming to the semiconductors, here there are a huge forbidden energy gap between the valency band and conduction band. If the electrons present in valency band, if they absorb some amount of energy and activated and went to the conduction band, here all the electrons do not reach the conduction band because they lose some amount of energy. Only few of electrons will reach the conduction band. So that's why the semiconductors partially conduct the electricity. That means when compared to the conductors, these semiconductors are having the lowest conductance. And the next one is the insulator. Here there are a huge energy gap in between the valency band and the conduction band. And hence if the electrons absorbs energy and they not enter into the conduction band. So that's why they will not conduct the electricity. This is the classification. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.